for today. So we're just going to do a brief overview of how we can understand how to use R for data analysis or research. So I would like some people to join me hands-on. So your time, let's go straight to the point. So I'll start by introducing R as a powerful software for research. So let's take a presentation. This slide, we're going to talk on what's R, the key features of R, its application in research, the advantages of R or Python, and then we'll conclude. So let's dive in. So let's talk on the history of R. R was actually developed by two men. The first was Ross Ihaka and Robert Gentleman, the second person. It was developed in the 1990s. That was when it was developed, but it was officially released into the world for usage or into the public from 2000. That is when it was released. So just like we know other programming languages like Java, Python, Ruby, and the rest, R is also an open source for functional programming language. So it's a functional programming language, and not just a functional programming language. It's also a statistical software programming language. So we use R to run a lot of statistical analysis. It was just designed for statistics at first, but with time, they found that more development occurred in R, so they started using it for data sciences and the rest. So the key features of R, as I said before, is basically used for running statistical tests. You can mention any kind of statistical test you know. R is actually created for that, like chi-square test, t-test, ANOVA. You can run some statistical assumptions by trying to actually confirm if your tests are actually following the right pattern. So we run statistical assumptions on that, and R can perform that. We also use it for running graphical analysis. Talk on plots, talk on packages like ggplot, which is a very important package. So you can run machine learning using R, supervised, unsupervised learning, and R is quite extensive. It has a large number of packages. So these packages are what helps analysts or scientists or researchers use R properly to run massive amount of data sets to extract insights. So there are a lot of packages that are created, and they keep on creating packages just to help statisticians make their life easy without running complex codes. So the next is its application in research. So as I said, R can be used for data analysis, not just data analysis. It can be used in other industries such as the healthcare industry, bioinformatics, used in social sciences, in finance, pharmaceutical industries, lots of industries. As far as data is concerned, and as far as they need to actually extract insight from data, R can be applied in any industry. So you can see from analyzing public health data or epidemiological data to running biological data, genomics data for bioinformatics, statistical analysis and survey, social experiments, risk assessments, portfolio management for finance, even down to machine learning and deep learning. There are packages in R that can help you do that. So advantages of using R. Why should we use R? What are the advantages? What will you benefit from using R? Number one is open source, so it's free to use. You don't need to actually pay or subscribe to use R. As I showed you, you just go to the website, you download it, then you can start using it. And then its programmability. So you see, it's easy to use with a wide range of package for specific tasks, making code concise, efficient, and reproducible. So you can write codes in R. If some codes are quite difficult for you, you can check the documentations, how to go about it. So R is very powerful and it's very nice to use. I mean, some people might find it difficult using at first, but with time, you come to understand that it's like one of the best things you can use for data analysis. And you can use it to produce reproducible analysis reports. We talk on things like R Markdown and the rest. So all those things is what you use for reproducibility. And R is compatible. You know, when we went through the download section, you saw where you can download for Windows or for Mac or Linux. So it's compatible with different operating systems. It's not just maybe for Mac or for Linux or Windows. You can run it on any operating system because it's highly compatible and open source. So R has a very large community of support. So in a situation where you fall into situations where you need to make inquiries or ask questions, or maybe you have issues running a code or something to understand what is happening, there are places where you can actually go and meet people, discuss it, share ideas. You can check on Tidy Tuesday. On Twitter, you can check R Stats community. And then for the ladies that are using R, they have their own community of R ladies. So now you have talked on the advantages. Is it that R doesn't have a downside or no disadvantages? Compared to the advantages, there are just a little disadvantage with using R, but it's not even noticeable. So at some point, it could be slow with complex data sets, as R execution are compiled and the speed is based on the RAM efficiency. So in a situation, maybe you are using a computer with a low RAM size, maybe 4 gig or 2 gig or 3 gig, and then you want to run data sets with thousands to millions of rows. Someone that is using a faster computer or a more graphics end computer will actually run those code efficiently compared to yours, because as you can see, our execution are compiled and the speed is based on your RAM efficiency. So if you have a better RAM, you're good to go. You have no issue. But in a situation where where you don't have that leverage, or you don't have that kind of support on your computer, and then you need to run millions of rows, observations. You need to run analysis on millions of observations. There are things like big data tools like Aperture Spark. You can use in R to help run your executions in parallel without actually eating up your computer efficiencies and heating up your PC. So that is the downsides. But you won't even notice until you start analyzing thousands and millions of data sets. So for now, we're just working with something achievable. Okay, so the interesting part, I know people will be asking, why are we using R? And then we'll be hearing about Python. Can't we use Python too for data analysis or research? Yes, you can use Python for that. But now, look at the purposes. Python is a general programming language. Web development can be used for web development, can be used for data sciences. It can also be used for gaming and automation. So there is a wide range of usage for Python. But if you look at R is just basically used for statistics, data science. It's just data, anything data, not for making webs, applications, or designing games, all those kind of things. So R is just specialized for running analysis, statistics. So the ease of learning, programmers or people that have prior programming language might find Python easy to pick, but R, because of the way the packages are developed and easy to understand, is very good for researchers who doesn't have a lot of programming knowledge. So its performance, as we said before, you can see it to some extent. R might be slow compared to Python because Python is optimized for this kind of tasks, so it tends to be faster. Getting to the integrated development environment, which is the IDE. As you know, when we were downloading it, we talked on the R program itself and then the IDE, that is R Studio, where we run our code. So R has more flexible IDE compared to Python. Some people might have issues with the flexibility of R IDE, but with little practice, you get to understand it better. You feel better using it, and you feel more confident, and then you won't feel happier using it because you're seeing everything at a place. And then its use case, as we said, R is mostly used in academia, research, bioinformatics. So you will not see R used in web development or automation compared to Python. Okay, so let's go to the last. So this course on R will be based on exploring the basic use of R and its application to public health data. But for now, we're not going to go in depth. So I'm not going to, after this, I'm going to give you a brief overview of how powerful R can be used to run data analysis, to make some kind of just a simple machine learning algorithm. You can use it for data manipulation, talk on how to import data. But we'll just touch a little bit on them. But for those going to register for the main course, you will get to understand in depth how to import data. You understand the data structures like vectors, matrices, and data frame. Talk on data cleaning and preprocessing, how we handle missing values for data that is not complete. Also talk on data transformation. We'll talk on data wrangling. So going next to that, we'll do some data analysis, do data visualization, and then we'll see how we can use R to explore some statistical analysis. All those hypothesis testing on ANOVA, t-tests, linear regression, which is kind of machine learning algorithm. So all this will be covered in the main course. So for now, we'll go over to R Studio. So first of all, let's go over to the internet. Okay, let's start. This is how it's going to be. So when you install R, there are going to be 4 panes. We call this 4 section. 1, 2, 3. It's 1, 2, 3, 4. We call them panes. P-A-N-E-S. 4 panes. So when I was presenting, we said the R Studio has a flexible IDE, which I also explained that some people might find it difficult at first. But with better explanation, you come to understand it's actually one of the best IDEs you can use. So here is called the source pane. This is where we put codes. And then down here is the console. You can see it's written console. So this is where our codes are being. This is where we see the output of our codes, the console panes. And then by the top right hand, you see the environment pane. You can see it says empty. So this place is where we see our objects that are assigned or values that are assigned or data sets that has been loaded. So we see it on the environment pane. Getting to the next tab here, you see connection. So here perhaps you want to connect SQL, PostgreSQL, MySQL, any kind of database connection you want to use. There's some kind of code you actually type on the source code to make it appear. So the last one I used was Spark, which is Apache Spark for running big data analysis. So that's why you see its connection here. So we're not going to go deep into this. So this one is more advanced. So the main focus is just the environment, which you also see how it works with some codes. Now coming down here, majorly what we actually see here is our plot. So remember where we put our codes, where our code is being executed, where we see our data, our objects or values that we assigned, which is here. And then here is for the graphs. And another thing we can also check here is the files. Maybe we have some files in our folders. You can access it here, just like on your desktop. So another one here is the packages. So as I told you, R has thousands of packages, over 18,000 packages on R. So for us to run some simple statistical analysis or some graphs or some simple data cleaning or even manipulation, there are packages that can help us do that with just writing a single or max 2 lines of code without writing complex codes. So that's why we say R was actually made for statisticians with not a lot of prior programming experience. So those packages makes life easy for them and for us. So this is it. So the help section is where we actually, for example, maybe we want to use a particular function or a package and we don't understand how to use that function for the code. We can just come here. Let's say, for example, we want to type count. We can come here and type count and click enter. So it will tell us the meaning of count function for that particular code you want to put in, and then tell us how to use the count function. So you see, apart from it being a functional programming language for running statistical tests, it also has a very good documentation that can help researchers read through and apply this knowledge on their code, which is on the source plane here, to actually achieve what they want to achieve. So the basic things we need to know here is for the files, here is for the plots and the packages, and then the help section. Okay. So if we want to run a new script, for example, we can come to this place, file. When you click on file, you see new file, and then click R script. It opens up a new script for us. So by default, once you open here, there's always a new script open. Okay. So let me show you an example of why I say here is for the codes and here is for the output. So let's run a simple code. Let's say 1 plus 2. So we see it down here, 1 plus 2 is giving us 3. So that is just it. We can run another one. 2 divided by 4. It gives us 0.5. So let's clean this. So if you want to actually run a code, as I said before, 1 plus 1, the best thing for beginners who once you type the code, you come here, there's what they wrote to run. You click on run. It brings out the results for you, which is 3. But as you progress and you get more accustomed to it, there are some codes you can just type on your keyboard. So for you to run this on the keyboard, you just type Control and enter. So when you hold Control and enter, you get 3. But for people using Mac, I think it's Command and enter. I'm not conversant with using Mac. So this command is for Windows key, Control and enter. So this is what you get. Okay, so let's clean this and let me put you on some exciting thing in R. So I have a script here. Yeah. Okay. So another thing I'd like you to understand before we go into these codes over here, you can adjust these panes. So let's say you want to adjust, you can push this, you can bring down this one, you can take it up. Maybe you want to see your graph better, you can take your graph bit up, push it this way, you see your plot. So it's adjustable. However you want it is adjustable. So since I'm actually trying to make us understand how to use R, so I'll want to expand the source pane. And another thing we're going to talk about is the appearance. Once you install your R Studio and you open your R Studio, you will not see a dark theme. I'm working on a dark theme presently because of its night, and I prefer using it. But some people might prefer a bright theme. So if you want to change the theme, you can go to Tools, Global Option. You go to Appearance. So here I'm using Tomorrow Night Bright, which is the theme I'm using. But I think by default, some people might see Chrome. So this is how it's going to appear by default. You're going to see it's white like this. So let me apply it so you see what I'm talking about. So this is how it's going to look like when you install it for the first time.
I think I prefer this one, the black one.
Okay, you prefer this one?
I prefer the black one.
Okay, prefer the dark one. Okay, why I put the dark one? Because I actually prefer it for when I'm coding, and then I think it's better off too when you're actually trying to make people understand how to use it, because it's this kind of, it has this contrast color. So let me change it back. So there are many of the dark ones. Some people can use tomorrow night. They have the 80, they have the blue. So I'm using the bright. So let me apply it back. So it switches back, which is fine. Okay. So now let us see how R can be used for research. I'm just going to give you an overview. I'm not going in depth, just some basic things. So R is a powerful tool for data analysis and visualization, widely used in research across various fields. So the scripts will help beginners to get started in R, covering the basics of data manipulation and visualization. So these are the basic things we'll know here. We're not going in depth. So it's just an introductory live section. So they say install necessary packages. So as I said before, we have over 18,000 packages in R, and these packages are what helps researchers, statisticians, bioinformaticians, data scientists, or analysts analyze data comfortably, easily, without writing complex and kind of hectic codes. So that's why we need packages. That's why R has a lot of packages. So this is it. So what is written is, uncomment the following lines to install the required package if you haven't already. So I already have these packages, but let us uncomment it so you see what I'm talking about. So when you uncomment it, you can see the function install packages is a function in R. So for you to actually get packages into your R environment, you need to install packages. So you need to call on that function, this function called install.packages, which is very important. So there's a particular package called the tidyverse. The tidyverse is like one of the important, or if not the most important, packages used in R. Some people must have heard of something like pandas in Python. If you are actually new to R, you are going to come to hear about the tidyverse, which is one of the most important functions or packages we use for running data analysis in R. So this is the tidyverse. So for you to actually work smoothly, analyze data, you need to install this package. And then this package, so let me put a reference there. So this is for this install read Excel. This read Excel is a package you use to read Excel file. So I've wanted to brief you on something. This tidyverse package has over 6 to almost about 8 packages in it. So it's like a grand package with other packages inside. So it has like 6 or 8 other packages in it. So for data manipulation, visualization, importation of CSV files, we have it in the tidyverse. But this read Excel package now is not in this tidyverse. So it's on its own. So you need to actually install it separately. You need to actually install it separately. So it's for Excel data. Oh, sorry, hold on. Okay. So the next thing I would like us to understand is how to assign variables in R. Now R is a programming language, so you need time to understand it. But for you to actually come to like R, you need to know what they call assignment function, the assignment syntax. So you see this syntax here, let me uncomment it for you to see it clearer. So why I always put a comment here is because I'm trying to make you understand what's happening here. So I comment it, but if I don't comment it, R will start seeing this thing as a code. So I don't want R to see these things as code. I want it to see it as just like a comment. You understand? So that's why I put comments in all these ones that you see comments. That is hashtag. We use it for commenting in R. So this arrow, backward arrow, means is used in R to assign values to objects or variables. So let us see how we can use this. So for example, we type 10. If we type 10 and we run it, let us run 10 now. You can see it on our source page where we see our results. It's showing us 10. So let's run 5. You can use Control Enter to run. So we see it, we have 5 down here. So you see all these things is showing on our console plane. So let's go back. So now we want to assign this 10 now. We want to assign this 10 to become X, and then assign this 5 to become Y. In the essence that anywhere we type Y or X, it gives us 5 and 10 respectively. So now, let's run this code. Use Control Enter. So now remember what I told you here is for assigning variables. We use here to assign variables and data. So now you see it has assigned the value 10 to X. So now you're seeing why I say R is a flexible IDE. So you are seeing your code here, seeing your results here, seeing the data, the variables or the objects you are assigning here, and then here is for the plot. We'll come down to plotting after. So let's assign 5 to Y. So this is it. We have it here too. Y, 5 is now Y. So let's print it. So we'll call the print function. So there's a function called print in R, which is the base R function. So when we call print, you just like type in, normally when you just type print. Okay, so you just type print. When we type print and we use the bracket function, automatically it will index this line, meaning that we can put whatever we want to put there. So that's how this code you see here for all of them, that's how it was written. So if we run this, Control Enter, you can see X now is showing us 10. So we print Y again, and when we print Y, it's showing us 5. So you can see that we have successfully assigned these numbers to these objects, and they are working perfectly. So this is just the basic way of assigning object in R. And then let's go to the basic arithmetic operations in R. So we have, now we know we already assigned 2 values, which is 10 and 5. So we have X here and we have 5, and we have X here and we have Y. So now instead of us typing 10 and typing Y, you can just type X plus Y, and then we're assigning it to a new variable called sum. You can assign it to anything. You can decide to even write Alex. You can write anything you want to write. It does not matter. You can just put anything you want to write. So whenever you run it, it will assign it here. So anytime you use this backward arrow, you are trying to assign value, and it will always appear in your environment. So now you see we have assigned X plus Y to sum, and then let us assign X times Y to product. We assign that for X. You assign Y minus X to difference, or just put anything you want to put there. You can write anything, and then we also apply for the last one. So now let's say we want to print these values using the print function. Let us know what is the meaning the value is giving us from each of these assignments was done. So we want to know the results. So we can just type the print function and then impute sum. So the print function and sum, you can see it down here, which is 15. So 10 plus 5 is equal to 15. We also print the product. X plus times Y is 50. And likewise others. Y minus X, here is Y minus X. And 5 minus 10 is equal to minus 5. So it's not X minus 5. So always be careful of how you actually code it in, which is very important. And then if you actually run the last one is giving us 2, because 10 divided by 5 is 2. So you can see how we can easily run basic R. We can easily run basic R operations, arithmetic operations, and then how we can use the print function. So next, let's talk on using basic. So we use other base R function. So we use other R base function. We're using R base functions. So there's something in R called concatenate. If you use Excel, I think there is a particular line of code, concatenate in Excel, but this is not Excel, this is R. So R doesn't use that concatenate function. Is what it uses here is just C. So this C function, we use C to group. You can use it to group numbers together. You can use it to group characters together. So that's what we use that C function from. That is the use of the C. You can also use it to group some codes together. So, but basically, we're just talking about how to group numbers and characters. When we get into the main course, we can talk about how we can group codes and other functions. So if you run this, you can see come here to run, or use your control and enter. So you see on the output, it is showing us that it has already taken this 1, 2, 3, 4 down to 10. So now you can apply. You want to check for the sum of these numbers. So you want to check for the sum of these numbers. So you can what you just have to do is come here and type sum, apply the first bracket, and then always go back, because if you are not actually correct, R will pop it out and tell you errors. So showing you errors already means there's a problem there. So you need to make sure the brackets are properly indexed. So there's an open bracket here, and then there's an open one here, and there are 2 inner ones. So you can see. So it's the same thing that we see down here. So when you run this, because we apply the sum function, it automatically, because as I said, R is a functional programming language, so it has inbuilt mathematical functions in it. So when you click on this, when you run it, it's showing us the sum of 1 to 10, which is 55. Now it gets more technical. So now what we want to do now is we want to, just like we assigned 5 and 10 and others up here, we want to group these particular numbers. We want to group them and then assign it to a value called numbers. So we're assigning it to a value called numbers. Remember, the assignment operator is always going backward and not forward. So we're assigning it to a new variable or object called numbers. So when we run this, you can see it has appeared there automatically, showing us that yes, we have succeeded in assigning 1 to 10 to be numbers. So now we don't need to start typing. So you can see we don't need to start typing a lot of codes now. So in this situation, maybe we'll have a lot of codes to analyze. We'll have a lot of data to